Here we're going to work our third weak acid, weak base problem, except this compound is a base. We know it's a base because our pH is 10.92. Now, because of simplicity, I don't want to keep writing this, so I'm going to designate this species as B. Okay? So it's going to work pretty much identically to the previous problems that we've worked, which are weak acids, except there's an extra step, because our step is this is a base. So remember, bases react with water to produce the conjugate acid plus hydroxide. Now, because this is the pH, I don't want the pH. I need the pOH, because remember, pH plus pOH is equal to pKw, which is equal to 14. That being the case, I know if I work this problem, my pOH is 14 minus 10.92, which is 3.08. Okay? So I'm going to need this in a minute, but I'll wait until I need to get to it. This is a simple equilibrium. So we have an ICE table. Well, initially we're supposed to have a concentration of X, 0, and 0. And remember, the water here is just acting as a provider of protons. It appears over here, but it's a small percentage, so therefore this is considered a pure substance and it does not take part in the equilibrium. But we know we're going to lose a certain amount. We're going to gain a certain amount here, gain a certain amount, and I'm using the delta as the change. So at the equilibrium, I end up with X minus delta, delta and delta. So wait a minute. I'm trying to find the equilibrium constant, so what I'm looking for is KB, is my big question. I've got two unknowns, so I have to have been given more information to provide. Well, actually now I'm at 3 unknowns, so I have to have given more information. Well, back here we said that the pOH is 3.08, and remember, the pOH is equal to the negative log of the OH minus concentration. That being the case, then I can determine the hydroxide concentration is going to be equal to 10 to the negative pOH, which is negative 3.08. So that gives me 8.3176 times 10 to the minus 4. That's going to be equal to my OH concentration and my BH plus concentration, which is also designated as my delta. So I could put it in here for both of these, 8.3176 times 10 to the minus 4. That's going to be equal to that and that, as well as over here, but we've got to find what X is. Wait. We were given the percent ionization. Well, remember, percent ionization is equal to the conjugate, which in this case is the acid form over the base form times 100. We're given the percent ionization, which is 19.3%. We now know that the BH plus is 8.3176 times 10 to the minus 4. So we need the B concentration, or the base concentration, times 100. We do the math and we find out that the base concentration is equal to 0.0043097, which we've designated as X. Okay? So now we have 0.0043097 minus 8.3176 times 10 to the minus 4. So our value at equilibrium is equal to 0.00347789 molar. back to the original question. The original question is wanting the Kb. Well, Kb is equal to the BH plus times the hydroxide over the base. So we know that that's 8.3176 times 10 to the minus 4th squared divided by 0.00347789. Okay, so my Kb should come out to be equal to 1.9892 times 10 to the minus 4. Notice we're doing the exact same steps we did before with one extra step. Our extra step is to convert from pH to POH because our equilibrium involves our OH minus. For bases, we're going to have an extra step or two. Depends upon whether we're going forwards or backwards, but it works exactly the same way. You just have to remember that we're looking for bases. We have an OH minus concentration, not an H plus concentration.